please notice we just want to let them know that recording is being done.
Right. So recording is in progress, and probably everybody got a little message saying that's okay. Okay, welcome everybody. This talk started out by some of my systems engineering friends in Switzerland saying, Tom, would you hold a talk about the V model and improvements to it? So I started working on that, and then I got a request to hold a talk here, and I suggested, why don't I hold the same talk? So that sort of explains why we begin with the V model. Let's see, details here. It's a copy of the slides, PDF copy at this address and with this QR. And here's a nice little picture of the Oslo fjord from a place we take walks to near our home. Okay, so on with the talk. Let's see. I've had this happen before. You push the button and it does not go forward. There we go. But you push other buttons and it works. Okay, so on the left-hand side is a rough outline of things I'm going to be talking about. And on the right-hand side, we have the V model, which basically is sort of a waterfall model. It doesn't seem to be very agile. And it basically says, design the system and then test it. And I'm going to talk about doing less testing and correction on the right-hand side and a lot of things you can do on the left-hand side to make that possible and make it economic. Okay. Here's another version of it for Department of Transportation, and it's very clearly a waterfall model. There's no sign of agile raising its ugly head. And I think this is from 2009. I'm going to use the term shift left, in other words, shift from the right-hand side with a lot of testing, really, and to the left-hand side. And here's a list of things. For example, we're going to start with the assumption that we're going to be doing this agile. We're going to start with the assumption that any kind of specification, like requirements or design, we can use what we used to call software inspection, but we'll call it specification quality control for the moment. We can use that at this stage to radically reduce the flow of defects into the finished system. We can also use quality assurance, such as the defect prevention process, which has been used in Minnesota at the IBM labs, to change the process maybe hundreds of times a year, small changes to tackle root causes of defects and prevent the flow of defects at all at this stage. I'm going to talk about advanced specification languages for requirements and design, which are more intelligible than things like user stories or other forms of requirements that you would know, and are highly amenable to digital understanding. I'm not going to talk about eliminating all testing. I think I think you still are going to have to run tests, but hopefully with fewer defect interruptions and corrections and retesting. So it's the rework is going to be the major reduction, and history says that is the main major reduction. And it, in fact, the reduction in rework is something like about 15 times what it would be if you didn't do what I'm talking about here, according to, for example, experience at Raytheon, to mention one place which has measured it, and we have case studies for. So I believe we're going to talk about a big reduction in defects found in the test by at least 10 times, maybe 100 times, if we're doing all the techniques very well. And this will result in faster delivery, fewer defects, and earlier delivery of value. Another little thing here to note is that the cost of tackling the defects on the right-hand side is about 10 times as much as the cost of tackling the defects on the left-hand side. And I'm sure many of you know that. 9.3 is something we measured and published in the software inspection book from an English client of mine. Okay, so here I've taken the shift left and just emphasized that we're going to do more there and put some little spirals here to emphasize we're going to be doing it in an agile way. And I like to think in terms of a value stream delivery early and continuously. Nothing near Big Bang anywhere or waterfall, and practical feedback from interested stakeholders and cumulative learning about everything is what we're going to be looking to see. Here's a diagram I found where it quite simply speaks to me and says we're going to invest more upfront on the left and end up with far less of the time and effort that is normally needed in testing and rework in later stages. I just attended a meeting earlier today where hosted by this guy called Steve Blank. He works a lot at Stanford. Very interesting. You have his URL there. You can subscribe to his weekly newsletter. He's one of the few people who I really read every week because he's got so much interesting stuff going on. And I just took one of his slides and I just love this list of legacy system thinking down here on the left, and this large collection of very interesting concepts, which he says are the future, in this case, for the US Department of Defense necessary, and some of them pretty radical steps forward, like attributable, and I've defined attributable down there, swarm of assets, just that concept alone, and you go down and you can get more information from this, but I think it describes a new environment in which certainly the US Department of Defense acknowledges they've got to build things. They're also moving away from building huge systems to building very low cost systems and things that can really easily be changed to whatever war or terrorist action or problem you have at hand. So it's a major shift from Department of Defense as we knew it. I think you'll find all that very interesting. Here's another, I'm emphasizing, usually it's a good idea to start with better and better requirements. I think requirements are atrocious. Oopsie, going back. I think requirements are atrociously done wherever I see them. I'm not impressed by anything. I can give you my own book on value requirements. And here's a related one on stakeholders that I wrote at the summer last year. This guy's interesting because he's working really at the CMMI, and he's developing processes for requirements which are very mature. So I just think that this list of disciplines within requirements is interesting, and what he has to say about them is interesting too. My own requirements language is called Planguage, planning language. We'll get back to that later. And all the things he's asking for can be done with my planning language. Here's another interesting fellow worth looking at. The thing he does, which is particularly charming here, is he is very, very agile. Here's agile. He also calls things evolutionary, which was my early word for agile, and very incremental. And I think the diagram alone is a study. So I give you the link and have fun with it, but it does show a very mature software or systems engineering environment with a lot of interesting concepts. There's our requirements friend there. And yet another one from Department of Defense, where what I like about it is it's very, very clearly agile iterations and loops all over the place, and that's where we need to go. And that's enough of that, and there's links there if people want to look at that. Now, I'm going to talk about my own methods, which are squirreled away in my competitive engineering book, which is the last paper book I published. So if you want a paper copy, you can still get it. But if you want a free PDF, there's a link here, and I'll give that link several more times. But that is that book is basically the definition of my planning language, and it is a systems engineering language. That is, it's not just for software. It can be used just for software, but it can be used for any kind of systems engineering. For example, we've used it on Medtronic products like the programmer for their pacemaker. Take one example. And the main areas of the language are requirements, design or architecture, specification, quality control, formerly known as inspection, and evolutionary value delivery, or incremental project management, if you like. I was having a discussion this fall with a good friend of mine who was thoroughly fed up with Agile and everything to do with it. Everybody screws it up everywhere. And you're going to have a debate on that soon. So here's my 5 cents. But what I finally said to him is said, we should stop fighting bad Agile. It's a lost cause. Let's reorient ourselves towards why anybody wants any kind of Agile, good or bad. And that's because they want to succeed. Let's orient ourselves towards succeeding in projects and not failing. And so just for fun, I wrote a little booklet, which I'm giving you a free copy of down here, tinyurl.com /success_Gilb. And you can read about my opinion about how to always manage to always get success and never fail. And here are some of the elements of it, and they're all covered in detail in the book. But of course, we start with really good definitions of success, in other words, requirements engineering. And then we start with really advanced architecture, which is multi-dimensional and quantified. I'll show you some more of that. There's a little book on it there, which you'll find at the very back in the references, and lots of other stuff, which I hope some of you will want to delve into. Okay. I held a talk about agility, my 2 cents, and I've picked a couple slides from it, and I decided to rename my style of agility Managility. And so I have here what I call a hypothesis about better agile methods. And the link to the talk is down there if you want more detail, and some kind of an outline is here. But let's make a long story short there. Whatever I do, it's multi-dimensional, and it is quantitative about all values and qualities and costs simultaneously. And in other words, we've moved into an engineering world where even though we're managing software, we're not primarily in a programming world. And that's a tough leap for some, but a necessary leap for others. Here's another slide from Managility with sort of a nice overview. Just in the last hour or two, I put in some simple examples of what I mean by strategies and multi-value control and quantified QC. We're going to look at that in a bigger slide later, and multi-dimensional values and costs, And then the whole agile process, here's my plan, do, study, act cycle, if you like. And with decomposition of strategies, I have special methods for decomposition. Anyway, more detail on that in the set of slides called Managility, which is my 5 cents about how agile should be done. I don't think agile is as important as the focus on successful delivery of value to stakeholders. If I could successfully deliver the value that stakeholders wanted without doing any form of agile, I'd do it. But I believe that agile is probably a smart way of making it happen earlier with more feedback and learning. So here's had 10 principles in the Managility thing. So here is one of the principles that basically says, you know, we should have digital tools for doing this, where the tools understood the requirements digitally and they understood the degree of goodness of the strategies and architecture digitally, and we could add it all up and get an overview picture. In other words, we could do the engineering with digital tools. And here's a list of all the advantages you get if you do use a digital tool. And the good news is we have in the last 7 years developed a really good digital tool that I use all the time. And you can look into it there. This, if you like, this replaces what we used earlier, spreadsheets and Word and things like that. But if anybody's interested in the...
Sorry, could you say that again? Sorry, I couldn't hear what...
Can't believe it. If anybody's interested in the digitization of requirements integrated with design and architecture, value delivery, and getting the whole picture of multi-dimensional quantified requirements and costs, this is a way of doing that more automatically than we've been able to do. But we use spreadsheets for about 20 or 30 years to do this kind of table. Here, what I'm actually doing in language and with these tools, if you say, what's all this stuff you have, Tom? I say, well, actually, it's just about learning to communicate more clearly. So for the fun of it, I wrote a book called Clear Communication, which you can get if you want to look at my methods of clarifying things. But for example, in simple terms, any quality or value, which is a variable, I will always quantify, no exceptions, no bullshit, okay? You don't have to go any further than a user story to find nice sounding words and no quantification whatsoever. Whenever I'm evaluating a strategy, I will always try to estimate and later measure the degree to which that strategy delivers my projected goal or value. So, and in other words, I get a very clear idea of how good is my strategy in multiple dimensions. I can have multiple cost ideas, and I can look at the value to cost ratio, and absolutely all of the critical objectives, which I call value objectives, and all of the costs are quantified. So we're moving from a programming world, which has virtually no quantification, into an engineering world, looking at the really critical ideas and trying to design them in, architect them in, not to code them in or test them in or anything silly like that. So enjoy clear communication. By the way, if you hit a paywall in anything I put here, I try to give the free copies of things, and you're a poor student and you write me an email, I'll give you a free copy. I don't really want to charge anybody, but some of these things are on my website behind a paywall. Here's an example of the advanced inspections we're doing now. We about 20 years ago, we stopped calling them inspections and started calling them specification quality control. And you'll find the detail on that in the competitive engineering book and some in the software inspection book. One of my favorite clients is called Intel. and they do research. They do my language for their requirements, and then they do the specification quality control for their quality control requirements. And you can imagine why Intel is terribly interested in getting it right early, because by the time it's made into a chip and spread around the world, it's too late. It's no longer software, it's hard. So they are fanatically devoted to very high quality. And so this is a paper of several published by John Terzakis, who is now with Raytheon, by the way. And it specifically says they're using my language and using this specification quality control. And here's an example. A set of requirements is with 31 pages is handed to quality control. They find, pages are 600 words, by the way. They find against a set of rules like should not be ambiguous, should be clear, should be consistent, should be complete, that kind of common sense rules about requirements. They find 312 defects, so that's 10 per page. Now, they have a thing called an exit level, and they've computed what exit levels they have to go for that pay off. And it turns out 10 is 50 times higher than is cost effective. So they say, no exit, go back, try again, try to follow the rules. So the team rewrites, do whatever they have to do, and gradually gets better and better and better until on the second, third, fourth, fifth, sixth iteration, they've got a 45-page requirements document with only 10 defects, which is 0.2 per page. Now, that turns out to be the level where it pays off to exit the requirements to their architecture process and anything else. Anything larger than that would cost them too much on the right-hand side of the V model, put it that way, especially because their software ends up hard. Okay. Now, by the way, getting only 10 defects per page here, that's actually about 10 or more times better than most clients that I experience when we first start quality controlling them. Sorry. Oh dear. Sorry, I went inadvertently too fast. They'd have 100 or 200 defects per page. So these guys come in at 10. Now, the reason they come in at 10, I'm pretty sure, because I have several measures of it, is because they're using my planning language, which is so clear, and they've been trained properly in it on 2-day courses and things like that. So they come in at, for many people, it'd be a very good quality level, but at Raytheon, that still is 50 times worse than they require for their chip logic production. So we use specification quality control to drive at least beginners, people who've never been through this before, to be 50 times better before their requirements are released for any other purpose. So Intel has trained over 21,000 engineers over 2 decades in my methods and done research like this on the methods. So if you wonder if I just think my methods are good or somebody else does, here's a very nice form of proof. I recommend get and read the article and others written by John Terzakis. Okay, he does some really interesting research in later years on teams and how they're motivated for those who are interested in that. Motivation. I'm reading it right in the middle of reading this book. It's not a new book, but one of my friends recommended it, Bringing Out the Best in People. And it's really about positive motivation immediately after anything happens as the best thing since sliced bread. So, here we have an example. This is from McDonnell Douglas, which used my methods for aircraft engineering. Boeing later did them also on a very large scale. We're talking thousands of engineers adopting my specification quality control methods for engineering drawings. And they're going through this same curve that we saw for Intel. They start off with far too many defects, their work is refused at an early stage. They're in a sense motivated to learn what the rules were. McDonnell Douglas always had rules, but nobody had time to go on a course. When they shifted out like 1,000 engineers in a 2-year time, nobody could get trained, nobody had experience, nobody could be bothered to read the rules. So they just didn't follow any rules except their intuition of what they'd learned at engineering school. This at least teaches them. And in fact, this addition to the slide says that they recognize that this method was perhaps the most cost-effective method of training the engineers to do what they needed to do to get what the aircraft company needed to have to survive in business. Why have I suggested these methods? It's kind of self-serving, isn't it? But if I don't believe in them, shouldn't have developed them. So here's a list, but these are the best ones I know about. If anybody out there knows of anything that's better, please tell me. I will try to learn. I will evaluate it. I'll tell you what I think about it, and maybe I'll integrate it into my methods. But these methods have been measured and studied corporate-wide for decades, and I've collected all that stuff. So it's not just a theory this will work. It is. It has worked in industrial situations such as Intel, and we know it, and we have stable results from them. So, but they are engineering methods, and a lot of people just aren't willing to move from programming to engineering. By the way, Rick Dove is an interesting guy. In the 90s at Systems Engineering Conference, he was the first person I ever heard talking about agility. And there's his website, ParShift. You might like to get him to come and talk someday. I think he's great and deep and really knows agility far better than any of these people running around teaching Scrum or something like that. My methods are also designed to handle multiple dimensions simultaneously. They can be used for management problems like building a better development organization and technical levels such as architecture. And they're also scale free. That is, they work at any scale, large to extremely large. You don't have to get a special method like SAFe to scale up. And they're based on engineering and scientific principles. So that's why I'm suggesting those who want something better take a look. And what about permission to use the methods? And the simple thing is they're Creative Commons, they're freeware. Here's one, and here's another one quite recently where I've actually donated my methods to Ivar Jakobsen's Semat Essence, which is an attempt to collect methods and distribute them free to anybody who wants to just make their own collection by taking one sub-method at a time. And you don't have to buy a package of a method, like SAFe, for example. You pull in from any source, any sub-method, and if it works for you, that's fine, and it's free. So that's what Essence is doing for an Ivar Jakobsen. And this is my donation booklet. We're about 100 micro acts, we call them. Is my way of giving them away so that you don't have to do my whole method. You can do one of my 100 sub-methods or micro acts. And I think that's a nice idea. And anybody else who thinks they have some nice methods might like to consider donating it to the world. So I'm 81 years old, so I thought I'd better donate it before it was too late. They'll not automatically be transferred in my will. So no permission needed to use the methods, no costs. You can teach yourself off of the, for example, booklets and stuff I'm giving you, okay? But that doesn't stop anybody who wants to build a business in mastering the methods and helping other people learn them. Notice that Rick Dove has little loops here on the left-hand side of the V model. He's the only person who understood the idea of agility on the left-hand side there. Yeah, here's some examples of quality assurance methods. Again, I could hold a 1 hour to 1 day course on any one of these, so that's not going to happen right now. But I give just for fun, a simple little practical example. So using the ValPlan tool, here we have a set of stakeholders. Here with the red arrows, we have a set of values, and the light bulbs are bright ideas, also known as designs or strategies. Now, we also capture the fact that these things are related. So I can see that this stakeholder is related to the process control requirement and the bio-waste capability requirement and the building activity enablement requirement, okay? But I can also see that this stakeholder, called volunteers, is not related to any requirements. And the very definition of a stakeholder is that they are related to some requirements, otherwise they shouldn't be there. So we know that we now can detect that there is a missing requirements for the volunteers. They could be here, but nobody's attached them and said that the volunteers are interested in the usability requirement, for example. That needs to be put into the digital model, okay? Going back, we can also see that some of the requirements have multiple stakeholders. Okay, so that's, yeah, when we build these tables I showed you, we automatically give the information that there is a relationship between the requirements. And so that enables the digital system to automatically draw these things on a diagram, okay? I hope that was one simple example, both of digitization and how you can use it for quality control at the early stages of the left-hand side of the V, and there's a much longer list here. Now, I'd like to talk a little bit more about the defect prevention process. This was invented at IBM. It won a corporate award of over $50,000 for being invented at IBM. One of the best users of the defect prevention process was people at IBM Minnesota in Rochester, Steve Kahn reporting it. I think he was at our last meeting. And it is detailed in my book, Software Inspection is one place, and I've got some other links to the original work there. Now, the basic idea of defect prevention is that the grassroots people, the engineers, will analyze their flow of defects in inspections and tests, try to understand the root causes, and try to suggest a process change. At IBM in Minnesota, they implemented in about a 2-year period about 2,000 process changes, and everything went, of course, better as a result. IBM, unfortunately, never sold or pushed this method externally, so it was largely something that IBM knew about and other people never learned about, but I think it's time we went back and relearned the method. I'm busy studying Elon Musk's methods, proud driver of my third Tesla. They're wonderful vehicles. But he makes this happen by insisting that any small team on a production line for Tesla or doing the rockets or whatever, try to understand any weakness in their process or design, and on a daily basis, try improvements in practice. So that's, I would say, what Musk does, and is documented in my free book, Musk Methods, which I hope you will enjoy. The link is there. Is a fanatic, extreme version, but it explains why, for example, Musk has the safest cars in the world, amongst the 50 best safe cars, for example. Here's a Raytheon diagram of the defect prevention process, but it really is as simple as I said: delegate power and time to the working software and systems engineers to analyze their own flow of defects from any source, to try to understand the root causes, and to experimentally change and measure whether the change works. pretty simple idea, pretty powerful. And I'm really shocked that more university computer science teachers don't teach something like this. I'm sure that some of you have some relatives and friends in IBM Rochester who could tell you about the history of that. But it's documented in IBM Systems Journal under Steve Kahn's name. Okay. Here's Robert Mays, who invented the process. And there are two chapters in the software inspection book, one written by, going back and forth here. One written by Robert and the other written by me, and integrating it into the book as sources of that. So, and here's another simplified diagram of how defect prevention process works, but I've already told you that. Here's a very interesting case study from Raytheon, where their rework percentages was, this is basically the cost of having defects and bugs and fixing them and checking that they're well fixed, was 43% of all effort. That's normal, okay? But using the defect prevention process and inspection in combination, they quickly drove this down until, I think after this chart, we're down at 3%. I think Bill Curtis, who's going to speak to you shortly, gave me the data, how far they've driven it down by a factor of 10 to 1. So, and I think more people ought to be saying, how much rework do we have? And have we started a process of driving it down, which requires the use of inspection and defect prevention process. Here's another view of it from where in 1 year, you managed to tackle 50% of all your defects. Takes another 2 years to mature, so you get to 70%. And IBM in Minnesota had much higher numbers over a longer time period. I attended last meeting here with my good friend Capers Jones, who's just fantastic at collecting facts for us and things like that. So there's his website. He's got lots and lots of good freebies and lots of good books. But here are some defect prevention methods. So there are quite a few that he lists, and all of them have some validity. And it shows, so in other words, one could study the whole area, defect prevention, and any one of these probably have at least a one-day course and then implement it in your organization. So there's plenty of opportunity to do that. CMM level 5 was essentially the implementation of defect prevention as far as IBM was concerned in its time. Here, winding down, we have, yeah, we're going to do this on time. Here's the Musk's methods on a larger scale. Quite recently, he toured his rocket factory in Texas with a guy who knew a lot about rockets. So he opened up to the guy because he had respect for him, and he told him some. Actually, he's never written a book on his methods, but he does interviews, and people tell about what he did, who's worked with him, and you catch him on videos. But I started to collect. So he, in that he basically had 5 ideas plus a 6th idea, which we can call, you must be a systems engineer. And basically, he starts off saying, make the requirements less dumb. Good place to start. By the way, he emphasized that it's important to execute these 5 things in sequence. And he bitterly regrets the times he didn't use his own advice. And he started automating too early, for example, at the Tesla Model 3 factory. So, and he has this wonderful statement that assume requirements are wrong. Everyone's wrong, no matter who you are. Everyone's wrong some of the time. And he says basically the same thing about requirements. So this extreme skepticism of any given requirements and designs, I think is very healthy, because everything I see is full of defects, right, left, and center, and people have a tendency to just accept them because they were given from some higher instance, like the customer, or who has no idea of how to write clear requirements. And we know that, but we just push on, and then we end up getting all these problems in tests and things like that. Here's his second idea is about simplification of deleting things that are may seem to be necessary but really aren't. That includes early automated measurement that you don't need anymore because you've already got the total output of a set of processes is good enough. Let's see, more or less same thing here, simplifies in optimizing designs. Here's this fanatic accelerating the cycle time, and everybody working for him is under no illusion, their cycle time, they have to figure out how to make it go faster and faster and faster. So, for example, Volkswagen is envious of his remarkable ability to produce cars much faster than they can dream about. That kind of thing. I think it's 10 per hour, and Volkswagen dreams about 20 per hour. There's some interesting stuff there you'll find on the web. Find the automation, and finally the idea of thinking like a systems engineer. Even if you are doing software, that software is connected to people and machines and data, and it's about time we didn't pretend as though the whole world was an algorithm and nothing else, and took a bigger view of things. I rewrote these 5 ideas. They were just off the cuff from Musk. So I rewrote them in the way I would have advised him to rewrite them, knowing what he probably intended. Now, he might disagree with me, but at least it gives something for you to think about. What is he really saying, and could he have said it in a more elegant way? That's at least, in my humble opinion, how to do it. And I've written a few more pages I've written about 1 page about each of these in more detail for those who want to see it. You have to have respect for his methods for the obvious reasons he's so damn successful in what he does, and that includes his software. I mentioned car safety. I quite like this. Here's the 50 safest cars measured by National Highway Transport and Safety Administration, I guess that is. And the 3 safest cars are all Tesla models. That's not an accident. That is a result of using Musk's methods, not to mention the fact that Musk himself is fairly fanatic on the safety aspect, but he's fanatic on quite a few other qualities too. Another thing that's really interesting about Musk is that for decades, certainly in car manufacture, they have released to production about 30 changes, half software, half hardware, on every week. I mean, the hardware changes and some of the software changes are the things that other auto manufacturers save up until the next model comes out in a few years. Okay, so he's literally releasing a whole new Nvidia computer one Monday, and things like that. So this is he's doing agile as it should be. Imagine if you could have Elon Musk come to your debate on agile, because he arguably does it better than anybody on the planet, with the possible exception of Jeff Bezos, who's worth a study. He does many similar things there. So, but 27 increments a week, and I get about half of them on my current car as my download over-the-air changes to my Tesla 3 in this case. So it was the agile changes are still being delivered to me, even though I picked up my car in September, and they will be for several years. It's quite amazing, and they're making my car safer, and they're making it more user-friendly, and they're also screwing up sometimes with things I don't like the design of, but they'll fix that too. Musk keeps on talking about a concept called first principles, So here's some stuff about that. But let me summarize what's going on here. It says, for God's sake, don't just take the conventional designs that we all know and then try to tweak them. Start with a fresh slate and think of what might be possible within the laws of physics, as Musk says. And, this is being really creative and really brainstorming out of the box. Okay. And then everybody will, of course, laugh at you and said nobody does that. But Musk says, I think if we work hard at it, we'll maybe make it happen, and then we'll be the safest car in the world. Or I will have a personal fortune of $300 billion or something like that. Musk is, by the way, not driven by earning money, but by having incredible products and maybe getting us all to Mars one day to save the human race. Promise to say, I just read a book recently about Jeff Bezos by two of his former executives. Quite a good read. I don't think I've given the reference to it here, but in the book they had a thing where they had read this Edward Tufte book about not having PowerPoint, and they bought into it. And so this is around 2008 or 10 or something like that. And then so Bezos said, right, no PowerPoint presentations to top management ever from here on in. Your presentation will be 6 pages maximum of text. You will not give an oral presentation on it. Everything we need to know will be in the words in that, text. And then at the beginning of the meeting, we will all, Bezos included, spend 20 minutes reading that 6-page text. Nobody will hand this out in advance, and we will all have a common understanding, and we will have discussions based on the text we all read. And wow, that's interesting. Okay. So I noticed that there was a remark that Bezos was often, after the 20 minutes were up, still reading, still studying. And then he was the one who came up with the most interesting comments of what was wrong with the proposal. And one of his guys asked him, Jeff, how do you come up with these amazing insights? And he basically said, I take one sentence at a time and I analyze it to death, which is exactly Musk's principle number 1. And I realized that's what I do when I read requirements and design. I take each one sentence or statement and analyze the hell out of it. And that's what I do. So my recommendation, by the way, I wrote a whole book on the subject called Planalysis, which you could have a free copy of to know how I analyze things to death. I don't know if it's exactly what Jeff and Musk do, but good luck. Now, I've used about an hour, which is about right. Here's my almost last slide. If you want to follow me on Twitter or LinkedIn, this is where I announce every new book I write or every great book I'm reading that I think is fun. Here is to remind you the links to the slides. And at the very end of the slides, there are some detailed references to a lot of other writings, mainly by me, mainly free links. So have fun picking those up too. Okay, so I'm done. I did it within an hour, and we can talk about things.
I was going to take a picture of the where to get the PDF, but
yeah,
I can't do that because I'm.
It's at the top of this slide. The link is also at the top of this slide if you want to take a picture of that. However, if you want the QR, there it is.
They'll publish it. Thanks.
Now you know why I wanted you to all get a copy of it. So I got all these links hanging around. So I know that I went fast and my slides are ridiculously dense, but I'm actually hoping that the smart people here will want to pick up the ideas and study them in some depth. And I hope that many of the things here represent new and exciting ideas that teachers want to teach and engineers want to plug into their corporations. And if I can help anybody do that, just ask. But there's plenty in writing here. Open for questions, I think.
I'll see what's in the chat.
Thank you.
Says near Oslo.
Yeah, but that might be where he lives, but not necessarily.
Oh, yeah, true. But, if I were him,
There's no questions in the chat. I have a question.
Yes, go ahead.
This change of design and requirements inspections to the words quality control during the design and inspection phases, has that made a big impact on the acceptance of doing these activities?
Okay, thanks, Nick. Good question. Well, let me tell you what happened. It's a detail I hid from you all, but it's worth replying. At one point, working at Citigroup in London, the director for Europe and everything came to me and said, "Tom, we have a very complex organization, Citigroup, and I've learned one thing, that complex methods don't work in complex environments. We need simple methods." And he said, "I love your inspection book, and it's 500 pages of complexity. Can you give me a simple version of it, please?" So we did it. Same day, we wrote a one-page version. And we did one extreme simplification we did was we went to sampling rather than the old style inspection went through everything and tried to find all the defects. Okay. But we went to sampling and we tried to measure and extrapolate how many defects were there. So we could reduce the cost by a factor of about 100 to 1. We could take a 1% sample. Okay. And then we used the measures to give feedback saying, you may not exit. So in other words, it's compared to the original inspection that IBM and Fagan developed, this is a radical change. And therefore it has a new name, specification quality control. And I've written plenty on it. And it's, if anybody wants more than they got, they can ask me to send whatever I have. But basically it's designed to be on a one page and training not needed, but maybe a maximum of a half a day, which is quite different. We used to spend 1 week training everybody in the inspection method, for example, as evidenced by the 500 pages in the software inspection book. So radical change, and it works better, works faster, and it's a lot cheaper.
That's interesting. This is Dick Hedger again. So back in the, I'm from IBM Rochester. Back in the early days of the development of a System 38 in the early 70s, inspections were the rage in IBM.
Yeah, with good reason.
And Fagan got a lot of money for inventing them.
Yep, $50,000.
Fagan shows up in Rochester and teaches or gives some introduction on how to do it. It's very hard to get. It's culturally challenging, harder than anything else probably. But he comes back a year later and says, "You guys are doing it all wrong." And he had this rules that you do it my way or don't. There was no chance for you to improve it.
Right. He was sort of like the Pope. He insisted on compliance.
Yeah.
But
Alex,
when I went to sampling, Dick. Sorry. Go ahead.
How often about scaling down? I work in a company with 3 engineers. How would we adopt your principles to our product development that is small and short?
Okay. There was a page. Okay. There's a case study from a company called Confirm It. You'll find it on one of that page on agility.
Either do it this way.
Maybe dangerous. I won't try it. But if you go back to one of these manageability things, there's a little reference, a thing called confirm it. That's a case study of implementation of my methods with 16 developers for a worldwide software product. So let's put it this way. It's an example of a small company using the methods.
There's our group.
That simple answer. I've got lots more small companies like small startups using the methods.
Now,
Actually give you detail about it would probably be more than I should use in a question like this. So we could talk about it with a meeting or
okay. But yeah, it's just
emails or something like that. But I remember I said the methods scale up. And got a lot of evidence for that. That means we've proven, for example, at Intel, they work on very small projects like only 6 people at a team, but they also work at Intel largest product and most complex products. So the scale, I refer you again to the scaling URL I gave you, how things work at small and large scale. But they do.
sick.
I think I should stop there.
To them and to whoever interacts with them, and that's,
I hear somebody talking in the background, and if they want to ask a question, they're on.
Just the number of emails.
Or Dick, you want to pull a question from the chat if there are. I can see the chat myself, actually, but.
Okay, well, okay, good. You can go, you take over.
Okay. Let's see. Going to the back. Let's see. Anthony Harder. You mentioned a number of software traps we fall into. Also covered how to avoid these. Scope creep is another recurring software problem. I did not explicitly hear how your methods avoid scope creep. Okay. Right. Again, I should write a paper on that and send it to you, Anthony, if you but I'll give you some hints. For example, when I refer you to thing you'll find references to in the references at the end on what I call the top 10 critical objectives. What I do is I time box things. So any project, large or small, I start out capturing the top 10 most critical stakeholder values. I know there are many more, but I refuse to deal with them until we've established the top 10, and then we start working on the top 10 until we've reached the goal for all of them, and then we look at number 11. So in other words, by limiting myself to the high priority things first and dealing with them, I effectively avoid scope creep, because the scope keeps on creeping in there, but I put them in a little box called, these were not the top 10. And we're working on the top 10. And when we're done with the top 10, we will evaluate your scope creep idea to see if it is high priority or not. Okay. Now, a second example there is, before I take in any design idea or any requirement, I look at the value to cost ratio. I call it the efficiency. And I prioritize based on value to cost. What that means is, scope can creep all it wants, but if it can't show a good value to cost thing, it's not going to get up there and get done in an agile environment. You can say, in agile, scope creep is really not a threat. It's only a threat, I think, in any kind of big bang thing. Now, those are my simple answers. But if somebody says, Tom, would you write a paper on scope creep for me? I think I'll do it. Sounds like a good idea. I'll have a more thorough explanation. Anthony, was that okay for the moment?
That's okay. I'll
Okay,
be willing to review your paper.
good. Send me an email saying you promised to write me a paper on scope creep.
You got it.
Good. Alex, who worked with instruments, maybe at Medtronic, I asked him. Anyway, you mentioned this scales up, but how about down? I work in a company with 3 engineers. How would we adopt your principles to a production environment, small and short? Okay, so sort of same question as Dick had. What we found, and this is verified by experience at Intel, in writing in that paper about scaling up and down that I referenced on a slide. So look at that. But basically, the methods start for very small. I do a lot of projects with one person all the time. You know, I have several per week where I'm only working with one person and they're working on a startup or something else. That's normal. Okay, so one person start. But at places like Intel and Citigroup and other of the large Boeing, we have thousands of engineers using these things. And as I say at Intel, we know it scales up to huge because we've done it for decades. Okay, so in other words, it's not a matter of scaling down. The methods start at a very simple level, like the top 10 on one page, okay, which we do in an hour or two. And then, but this top 10 can apply to a huge project with 1,000 people working on it too. Okay, now, again, I've written the paper on scaling. If you're interested in this, please read that paper first. If you have further questions, I'll be, give me more examples of a really small scale. I recommend the reference to the confirm it. You'll find on one of the manageability slides with, there were a lot of references there on the right-hand side. That is very small scale in practice with very good business results. Okay for the moment, Alex, as a short answer to a short question?
Yes, thank you.
Okay. Ask for more by email if you get curious. Let's see. A message, stop recording now to conserve space. Okay, let's do that.